Hello, my name is Long, and this is for quiz 2. The first question asks, explain the relationship between big f of y and small f of y, and between big g of t and small g of t. So big f of y, if we just take derivative of this function right here, actually gives us 1 over small f of y. And big g of t, if we take derivative of big g of t, we just get small g of t. Question 2 says, explain why it is sufficient to use a single integration constant c. It's sufficient to use a single integration constant c because c is just a shortcut. So in this example here, if we do separation of variables and take an integral on both sides like so, we're going to have a constant integration on the left and on the right, which we call c1 and c2. So we can just say that the single integration of c is equivalent to c2 minus c1 if we subtract the left side over to the right side. Hence why when we do separation of variables, we're going to have something like this. A big f of y equals to big g of t plus c. Because we can just say that c is just a shortcut of c2 minus c1. That's why we only have one single integration constant of c. Integration constant c. And the last question says to explain why it's possible that a function of y on the left side equals function of t on the right side. So this is possible because once we have big f of y equal to g of t plus c, this is possible because big f of y actually contains a t in the function. So actually, if we perform the chain rule of d over dt, this works because it's actually big f of y of t. So if we do perform the chain rule and take derivative with respect to time or t on both sides, we will get 1 over f of y times dy over dt equals small g of t. And if we multiply f of y over, we can have the original function that we have to start in the beginning of dy over dt equals to fy of gt. And just to summarize it up, it works because a big f of y contains a t in it. So f of y of t right here. And this is why that the function of y equals to a function of time, g of t plus c.